You are sitting on a modern aircraft at 35,000 feet. The pilots are not flying by feel, they're flying by data. Every second, hundreds of sensors are feeding information into the system. Altitude, speed, attitude, position. The aircraft is not reacting to the outside world directly. It is reacting to what it is being told the world looks like. And if that data is wrong, the aircraft reacts to something that does not exist. I am a licensed aircraft maintenance engineer. I work on these systems, I sign them off before every flight, and I want to show you what avionics actually is, because this is not just electronics, this is what allows an aircraft to understand reality. Avionics. Aviation electronics. It is every electronic system that allows the aircraft to navigate, communicate, and operate safely, and not the engines, not the hydraulics. This is the intelligence layer, the nervous system of the aircraft. Every sensor on the airframe, every display in the cockpit, every navigation receiver, every warning system. All of that is avionics. And on a modern aircraft, there are hundreds of these units working together. Start with navigation. The aircraft does not rely on a single system to know where it is. It uses multiple sources at the same time. Inertial reference systems, GPS radio navigation aids, each one calculates position independently. Then they are compared. If something does not match, it is flagged. Now communication and monitoring. The aircraft is constantly talking to air traffic control, to other aircraft, to systems on the ground. A CARS can transmit faults before the aircraft even lands, and onboard systems monitor the environment continuously. For example, TCAS actively prevents mid-air collisions. It does not wait for the crew to react. It commands avoidance when required. At the center of all of this is data processing. Systems like ADIRS take raw sensor inputs and convert them into usable flight information. Airspeed, altitude, attitude, vertical speed. The pilots do not see raw data, they see processed information. Then comes the flight management system. The FMS holds the route, the performance calculations, the fuel plan. It takes all available data and builds a complete picture of the flight. The autopilot follows that picture, and the aircraft responds to it. This is the critical point. The aircraft believes what it is told. If the data is correct, everything works. If the data is wrong, it reacts to a reality that does not exist. Air France Flight 447, June 2009, Airbus A330. Cruising over the South Atlantic at night, the pitot tubes iced over, those sensors measure airspeed. When they failed, the system received conflicting data. The autopilot disconnected. The flight control laws changed. The crew were now dealing with multiple instruments telling different stories. In the confusion, the aircraft entered a stall and did not recover. 228 people lost. The aircraft itself was not broken. The engines were still producing thrust. The failure was in the data, and that changed everything. After that accident, pitot tube standards were upgraded. Airlines changed procedures. Pilots were trained specifically for unreliable airspeed scenarios. Because aviation does not ignore failure, it isolates it, understands it, and removes it from the system. Now let me tell you what we look at on the ground. Before an aircraft flies, avionics systems are checked against the MEL, the minimum equipment list. If something is unserviceable, we do not guess. We either defer it correctly, or the aircraft does not fly. When an avionics unit is replaced, it is not just installed. It is configured, tested, verified against the aircraft systems, and then documented. And then someone signs, a licensed engineer. That signature means one thing. If the data is wrong, this aircraft does not leave the ground. Most people think avionics is what the pilots look at. Screens, instruments, displays. That is not what it is. Avionics does not support the aircraft. It defines what the aircraft thinks is real. It converts the physical world into information. The pilots trust that information. The systems act on that information. Everything depends on it. Avionics is not one system. It is hundreds of systems now working together to tell the aircraft what is happening. Redundancy, cross-checking, certification, every failure mode considered, every response defined. This is not convenience. This is controlled engineering. I have signed off these systems countless times. Every time at the same standard. Every time, the same consequence. The aircraft believes what it is told. The aircraft believes what it is told. Now, if you want to understand what's actually happening every time you fly, subscribe. See you in the next one.